Determine all roots of the equation z cubed plus a half into 1 plus j root 3 is equals to 0. Now, the first thing to do is to make z cubed the subject of the formula, isn't it? So if you make z cubed the subject of the formula, here we have z cubed plus a half into 1 plus j root 3. So you take that a half inside the bracket. So we have a half times 1 is a half plus a half times j root 3 is root 3 over 2j is equals to 0, isn't it? Are we together? So if you make z cubed the subject of the formula, we have z cubed is equals to positive a half going the other side is negative a half, isn't it? Then positive root 3 over 2j going the other side is negative root 3 over 2.
Yes.
So from there, that equation is in the form x plus jy, isn't it? So you can see your x is negative a half and your y is root 3 over 2. Because you can only solve a complex equation in polar form, isn't it? So you have to change this Cartesian form into polar form. X value here is negative a half and y value here is negative root 3 over 2 because the equation is the form x plus yj, isn't it? So what is r? So r is the Pythagoras theorem, that is square root of negative a half squared plus negative root 3 over 2 squared, because r is supposed to be the square root of x squared plus y squared, isn't it? So what do you find to be r? What do you find to be r? Square root of negative half squared is 1 over 4. Then plus negative root 3 over 2 squared is 3 over 4. So you get square root of 1. So square root of 1 is 1. So r is 1. After finding r, we look for theta. So theta is the tan inverse of y over x. So tan inverse of y over x is tan inverse of y value divided by x, root negative 3 over 2 divided by negative a half. So negative goes with negative, a half in the numerator cancelled with a half in the denominator, so we remain with tan inverse of root 3. So when you're looking for the tan inverse, you check which quadrant are you dealing with, isn't it? Which quadrant are you dealing with? You look at your x value. So if you draw the complex plane, the imaginary axis and the real axis, x is negative half, meaning x is negative, isn't it? Are you seeing that? So when x is negative, you go on the negative side of the real axis. Then y again is also negative. Are you seeing that? If y is negative, that is the negative side of the imaginary axis, isn't it? So you can see x is negative, y is negative, meaning that complex vector is in the third. It is in the third? It is in the third quadrant. So third quadrant, remember we have is 180 plus theta. So it means we need to get theta first. So what is the tan inverse of root 3? It's 60 degrees, isn't it? So tan inverse of root 3, the angle in the first quadrant is 60 degrees, but we need the angle in the third quadrant, which is 180 plus 60, isn't it? So in the third quadrant, tan inverse of root 3, we need 240 degrees. So those two at 240 degrees can generate many angles. You can add 360 to 8 or subtract 360 to 8 to get equivalent angles, isn't it? So if you start by subtracting 360 to 8, you get negative. If you add 360 to 8 you get, if you add 360 to 240, 600. Maybe if you add another 360, we get. So having done that, we've now found that z cubed, which is equals to a half, negative a half, minus root 3 over j, is simply in the form r angle theta, isn't it? In complex form. Are you together? It is in the form r angle theta. So remember we found r is equals to 1 and our theta values are, if you rearrange, negative 120, 240, 600, 60 degrees. So can we now solve for z? So we have z cubed is equals to r angle theta. So for you to get z, you multiply both sides of the equation by a third to get rid of the cube, isn't it? A third to get rid of the cube. So this side will remain with z. Then r raised to power a third. Then angle theta is a third theta because it is supposed to be, if you have r angle theta raised to power n, then it is r raised to power n theta, where theta is the argument and r is the modulus, isn't it? Are we together? So from there, we now substitute the value. So we start with the first solution, z1, r raised to power a third. So start with r raised to power third is 1 raised to power third. 1 raised to power anything is 1, isn't it? So all our r is 1, isn't it? So you found the first z1 is r is 1, then a third theta. So start with the first theta. A third of negative 120 is negative 40 degrees. So there we have negative 40 degrees. We are done with z1, isn't it? We go to z2. So z2 r raised to power third is 1, then angle a third theta. So a third of 40 degrees, 80 degrees. Then you move to the third one, z3. R raised to power third is 1, angle theta. A third of 600 degrees, 200 degrees. Then you move maybe to the last one. R raised to power third is a 1, angle. A third of 960, 320 degrees. So a third of 960 is 320 degrees. So having found all the solution in polar form, you can now convert them back into Cartesian form. Remember, in Cartesian form, it is x plus y, j, isn't it? So what is the rectangular form of r theta? So start with the first one. Rectangular form of 1, 40 degrees, because it is rectangular form of r, theta, isn't it? So what is the rectangular form of 1, 40 degrees, negative 40 degrees? X is 0.767, then y? Negative 0.642 times j. So it is x plus yj, isn't it? Then you move to the next one, the rectangular form of r theta. Our r is 1, our theta is 80 degrees. So what is the rectangular form of 1, 80 degrees? X is 0.174. 0.174. Just like that. And y?
0.984.
Positive 0.985, then j. So that is in the form x plus yj, isn't it? Move to the next one, rectangular form of 1, 200 degrees. Negative 0.9397. Then y?
Y is
Negative 0.342. Then y is times j. So you found it in the form x plus yj. Negative 0.342j. Then the next one, rectangular form of 1, 320 degrees. What is the value of x? 0.77. 0.77? 0.766. That is x is 0.766. Then y? Negative 0.643j. So you found x plus yj. X is 0.766, Y is negative 0.643J. So you found them in the form of X plus YJ. So that is how to solve a complex equation leaving your answer in Cartesian form. Next example.